Exercise 1.4, that's actually just a standard optimization exercise. We are asked to determine the optimal price and volume combination for the tickets and calculate the expected contribution margin. And in this case, we are given some information on the demand. We have a demand function here, and also on the costs for each ride. And the marginal cost for each ride is 5 kroners. So in exercises like this, we should first find marginal revenue. And we know that marginal revenue is equal to the demand function, but with the double slope. So we write MR equals minus 0.0004x plus 70. And we also know that marginal costs is equal to 5 Danish kroners. So we just write that as marginal cost equal to 5. So that's actually what we need to do this exercise. Then we set marginal revenue equal to marginal cost. Meaning that minus 0.004 x plus 70 is equal to 5. And then we have to calculate the value of x. In this case, we can use the graphical calculator and just type in our functions. First we type in the demand function. Next we type in marginal revenue. And next we type in marginal cost. In this case, marginal cost is a constant, meaning that it is just the average variable cost for each ride. I'll just change the graph settings a little bit, something like that, and then we can go down to 70 here, and we should get a nice picture. Yes, the intersection that we are looking for is the intersection between marginal revenue, which we have here, and marginal cost. And that tells us that it is optimal to reach the quantity of 162,500 rides. So that's what we write. X is equal to 162,500 rides. Next, insert x, which is equal to 162,500, into the demand function to find the price that we are able to charge for this amount of rides. And in this case, we can just look at the demand function up here, and we just have to find the point here at 162,500, and the price here is 37.5 Danish kroners. So that is the optimal price. If we should write the calculation for this point, it is equal to price, which is minus 0.002, and then instead of x, we simply just write multiplied with 162,500 plus 70, and then we get that the price is 37.5 Danish kroners. Next we should calculate the contribution margin, and this is done best using an Excel sheet, I think. So first we make a calculation for revenue. In this case, revenue is simply price times quantity. So we will write it like this: 37.5 times 162,500. And over here we just make the calculation. And we do like that. So that's the revenue. Next we have to find the variable cost, or abbreviated with VC. In this case, the variable cost will be the average variable cost per unit, that is 5 kroners. So that's when it's a constant, the average variable cost and the marginal cost is the same, are the same. In this case, they are both equal to 5 kroners. That's how much the first ride cost us extra, and the 1/1,000,000th ride cost us extra. Doesn't matter. So in this case we write 5 times 162,500, and we get variable costs. And lastly we write contribution margin, or just CM, and that's equal to revenue minus variable costs. And we can just do like this. And then that's it. So this part we can actually copy and place here. And if we have the time and just want to make sure that we have answered all the questions, we just write in conclusion the optimal quantity is 162,500 rides, and the optimal price is, in this case, 37.5 Danish kroners. The expected contribution margin is equal to 5,281,250 Danish kroners. So that's what we should write in this exercise, exercise 1.4.